Hi everyone, in this video we're going to learn how to solve the equation involved the logarithm. Here I have 8 examples on the log equation, and we learn how to solve it by finding the x. Here is my first example. The approach I'm going to use to solve this equation, I will check two things. Alright, the first thing is the base. I need to check whether they have the same base. If they're not having the same base, we need to change the base to be the same. So now both of them having the same base, then second thing we need to check the coefficient of the log. The coefficient of the log at the left hand side is 1, so it has been nicely we can solve without doing anything. But for the right hand side, we can see that the coefficient of the log is 2. So we need to change it into the 1. And how can we do that? We just bring the 2, become the power of 2. That is 4 power of 2. So now what I can do is I just remain the left hand side as a 2x base of 3. And the right hand side I converted into this 4 power of 2. Then now you can see that both of them having the single log. Since this is an equation, if both log left hand side and right hand side they having the same base, we can just compare the content of the log. That is, we can say that the 2x equals to the 4 power of 2. Where this is a linear equation, we can solve it by using the 4 power of 2 for square, which is 16 divided by 2. Then finally we got the 8. We always can check the answer by substituting the 8, the solution, back to the original equation. For example, substitute the 8 back here. I got my log 16 to the base of 3 at the left hand side. And at the right hand side, I got a 2 log 4 base of 3. If I bring the 2, become the power over here, I got 16. So it is equals, it will make the equation satisfied. That is a left hand side value equals to right hand side value. For the next example, we can see that we have compared to the question just now, we have a single log at the left hand side and single log at the right hand side. Alright, so the same thing happened to the example B. I got a single log at both sides, but again you can see that the coefficient of this left hand side log is not equal to 1. So again, I will apply the rules of laws of log. The third law of log will bring the 2 to become the power, then it will become like this. Right hand side will remain the same. Or you might change the log 9 to the base of 2. I think it's fine. And then after that, since the both sides, you can see that they're having the same log, that is having the base of 2. So means that the content of the log, that is x squared, x minus 1 squared, can be equals to 9, has to be equal to 9. So this is a quadratic equation. Using the method of solving the equation of quadratic, we're going to expand this first, bringing the 9 to the left hand side, trying to simplify by collecting all the like terms, meaning that you're taking the 1 minus 9, that is negative 8, equals to 0. Then trying to factorize it. 4 is consists of 8 it consists of 4 multiplied by 2. So this one has to be negative and this has to be positive. We can always expand it back to see if our expansion is correct. Then we got the two answers, that is x equals to 4, x equals to negative 2. And we are not sure that we're going to accept both as a final answer or one of it. So always we can substitute the value, the solution that we got it just now, substitute back into the equation, original equation. First we check the 4 first. Substitute 4 here, you will get the log 3 to the base of 2, log 3 to the base of 2, where the coefficient here is 2. Bringing the 2 here, you will have a log 9. So log 9 to the base of 2 at the left hand side is equal to the log 9 to the base of 2 at the right hand side. Then we can say that we are going to accept this as our answer. Okay, trying to check for the x equals to -2. Alright, I erase this off. Substitute the -2 here. You will have a log. -2 minus 1, you got -3. Once you got the log, the content inside this log is a negative number, then you will say that this has no solution, or we say something wrong, because this is impossible, because in the log here couldn't be a negative value. So we say that x equals to -2 will be discarded. And always make your choice at your last step. That is your x equals to 4. For the next example, different from the 2 examples just now, I got my question, I got 2 terms of log in my left hand side and a constant at the right hand side. And how do I solve this type of question? I would first combine these two by using the laws of log, because they are having the same base. So we can apply the laws of log to combine them by multiplying the 4 and the x together. And this is equals to 2. So now you've got a single log at the left hand side, and a constant to the is at the right hand side. You can always solve this type of equation by changing the log form into the index form. Alright, how can I do that? You can always check my previous video. There is a video showing you how to change the log form into the index form. So we can always do that by solving the x, changing into the index form. That is 4x equals to 5 power of 2. This is the base. So when you change it to the index form, the base of the index still will be the 5. Same with the base at the log here. And this is the power of the base. This is the power, and this is a 4x is the content of the log, should be located here. And now you got a x equals to 25 over 4. This is your answer, and we always can check our answer by substituting back the 25 over 4 into the x. Put the 25 over 4 here, you will get, you can always get the calculator help to check the value of the log 25 over 4 to the base of 5. You will get when you press the calculator, you're going to press your calculator like this, using as if that you have changed this log into the base of 10. You are pressing the calculator. First, put the log 25 over 4 and then over the log 5. Having the base of 10, this will give you a decimal number. Okay, and then plus the log 4 to the base of 5. Again, you always can press your calculator in this way, pressing the log 4 and then over log 5. Again, as if that you are changing this log into the base of 10. When you're taking this log, add by this log, you suppose will get the 2, where the 2 at the left hand side is equal to the 2 at the right hand side. Then we say that x equals to 25 over 4 is accepted as your final answer. Here is another example, the equation of the log, and I have 2 terms of log, 1 terms of constant. Similar to the question C just now, 2 terms of log and 1 term of the constant. Just now I have used the approach where I combine the log all together and then unite them by using these laws of log, the first laws of log, having the 4 multiplied by x. Then I got a single log at the left hand side and constant at the right hand side. I convert the log into the index form, then I solve for the x. For this question, for the following example, that is example D, I'm not going to use this approach, but actually you can use the same approach to solve for the D. But here I'm going to show you how I use the another alternative method to solve this type of equation. The first step I will apply is changing the 3 into the log form. So how can I change the 3 into the log form? Of course, you will choose the base first. So consider the rest of the log term having the base of 3. So here I also will put as a base of 3. And how do I change into the log form? That is, I'm taking the 3 here and power of 3, so that you will have the 3 back. If you want to change the log into the constant back, you will bring in a 3 to the front, and log 3 to the base of 3 is equals to 1. So back to the negative 3. Then this is equals to the log x to the base of 3. We just copy it down. Now we can combine these two terms of log, and this will become this example having the 3 terms of log. All the terms are having in the log form, and we need to check whether the base are the same. If they are the same, we can directly start to solve. When we want to solve again, we need to check, okay, the 2, I need to change it into 1. So how do I do that? I will bring in this 2, become the power of the 3. So here I have my log 5x minus 4 to the base of 5 equals to log 4 to the base of 5 plus bringing the 2 up, you got a 3 squared to the base of 5. So left hand side already in the single log, I will just copy it down, and the right hand side I need to combine them by taking the 4 multiplied by 9. Why can I do that? Because the plus over here, follow the laws of log, this is going to be multiplied. And now the content, we can compare it because both having the base 5. So I will say that the 5x minus 4 equals to 36. Then 5x equals to 36 plus 40, plus 40 plus 4 equals to 40. Then x equals to 8. Again, you can check your answer by substituting the 8 back to here. So 8, 5, 40, 40 minus 4, that will be 36. So check whether you can use your calculator to check the answer. Okay, check the value. Is it equals to 8? If yes, then you are going to accept this answer. Alright. So after you have gone through few examples just now, this should be the simple question for you. I'm going to combine these two because they're having the same base. Combine these two by using the laws of log. Because of the subtraction here, I'm going to take the 5x divided by 3x minus 1 to make it into the single log at the left hand side, and the 1 as a constant remain at the right hand side. So now I'm going to change this equation into the index form, that is 5x over 3x minus 1 equals to 4 power of 1. 4 power of 1, which is equal to 4. Then after that, multiply both sides by 3x minus 1. I got 4 multiplied by 3x minus 1. Then after that, expand it. Expand the right hand side. I got 12x minus 4. Then solve for this linear equation. I got my 7x. Alright, 7x equals to 4. Then x equals to 4 over 7. Again, you need to check the answer 4 over 7 by substituting the 4 over 7 into the x. With the help of calculator, check whether the left hand side value is equal to 1. Then you will know that your answer is correct. This is the last example in this video. Again, I got 2 terms of log and 1 term is in constant. So there are 2 methods again, 2 methods. The first method is bringing all the log to one side and left the constant at the other side, and combine the log term together, make it into the single log, and convert the single log, the equation, into the index, then solve for the x. The second method is changing the 1 into the log and then combine these 2 terms at the right hand side to become the single log, and then compare both sides. Alright, so maybe here for this example, I'm going to use the second method. I will change the 1 into the log form. That is log 6 to the base of 6, that it will be equals to 1 plus log x minus 5 to the base of 6. So combine these two by using the laws of log. I will have 6 multiplied by x minus 5. And the left hand side still remain as a log x to the base of 6. So now compare the content of the log at the both sides. Since the base have they're having the same base, we can compare. So x equals to 6x minus 30. Then 5x equals to 30. Alright, x equals to 6. Again, you can check the answer by substituting the 6 into here. This is very simple, very easy to check, because you got a log 6 to the base of 6 that is equals to 1. And then you have 6 minus 5 equals to 1. Log 1 will be 0, regardless the base. And 0 plus 1, you get 1. So both sides having the value of 1, we say that x equals to 6 will be is satisfying the equation. Then we accept it as our final answer. Okay, so thank you for watching.